We'll pick up this probability question from the 2018 Methods Exam 2 at this point here. So find the probability that a random sample of 16 Mathsland adults will contain exactly one person with a slow heart rate. So we know something about slow heart rates. From earlier in the question, the probability that a Mathsland person has a slow heart rate is this one here, 0.1587. Okay, so, and what we want to know is the chance of exactly one person having a slow heart rate. So it could be the first person, the second person, the third person, but all of the others have kind of like, should we say, a normal heart rate perhaps, or a standard heart rate. So this is clearly binomial. So let's define that as binomial. We're doing 16 samples, or grabbing 16 people, and the chance of finding what we're after, which is the slow heart rate, is that. And we want to know when the random variable is equal to 1. So yeah, pop that into PDF you can, or CDF. So we're going to do this 16 times. Chance of success 1587, and we want to know when the random variable is equal to 1. Zero 0.190, and need to include that third zero there, 3 decimal places. Alright, so here's where it gets really tricky. For random samples of 16 Mathsland adults, p hat is the random variable that represents the proportion of people who have a slow heart rate. So we're basically grabbing samples, and we simply do not know what we're going to get in the sample. Like, we could have none out of 16 with a slow heart rate. We could have 1 out of 16 with a slow heart rate. We could have 2 out of 16, all the way to 16 out of 16, just by some freakishly weird sample that all of them have a slow heart rate. But we know that this value here, I'm just going to get out the highlighter, this value here, 0, 1, 2, 16, 3, 4, 5, that's a binomial random variable, and that's what we've defined up here. Okay, so that's going to be binomially distributed. So all we need to do is basically work out this or use this value here, 10%, and how it relates to the 16 Mathsland adults. So the way I'm going to do that, let's write out probability p hat is greater than 10 out of 100 is the same as the probability that p hat. Let's convert it into this sample. So that would be 10% of the sample of 16, and that would be 1.6. Probability that p hat is greater than 1.6 out of 16. Now, what's that you say? You can't have 1.6 in a sample? No, you can't. So we want it more than 1.6. So this would be the same as the probability that p hat is greater than or equal to 2 out of 16. So really what we want to find out is the probability that p hat is 2 out of 16, 3 out of 16, 4 out of 16. So we want to basically sum together 2, 3, 4, 5, 6, 7, etc., etc. Now again, worth reflecting on the fact that this thing here is the thing that's binomially distributed. So we could work out 2 all the way to 16, and in fact, let's just do that. So we want the probability that we're going between 2 to 16 on this random variable that we defined earlier. Okay, and yeah, again, we'll just jump on CDF to do that. that's normal. Yeah, let's use that. Okay, so we're doing it 16 in the sample. Chance of success 0.1587, I think it was. And we're summing together samples of 2 all the way up to 16. That's what we want to know. What are the chances of this happening? 0.747. Yeah. Okay, so there is that. Okay, for random samples of n Mathsland adults, p hat n is the random variable that represents the proportion of people who have a slow heart rate. So we've kind of got a different random variable here that's based on a random sample of an unknown size. So we don't know the size of the sample. Find the least value of n for which the probability of this new random variable being greater than 1 out of n is larger than 0.99. Alright, it's pretty hard to wrap your scon around, but let's just see if we can think about what it's saying. So greater than 1 out of whatever it is, okay, greater than 0.999. So let's just have a guess, right? I don't know, what would the sample be? So let's just say we'll test n equals 10 and see what happens. So we're looking for the probability that the sample proportion is greater than 1 out of 10. So that'd be 2 out of 10, 3 out of 10, 4 out of 10 is larger than 0.99. Okay, so what I'm going to do is test it over here. So I'm going to go to CDF again. Oh my god, did the same thing. There it is. Okay, so we're doing this, I'm guessing, 10 times. We need to survey 10 people. The chance of success, same as always. Well, not the same as always, the same as before. The lower bound, so we want the sample proportion to be larger than 1 out of, so that's going to be 2 out of 10, 3 out of 10, 4 out of 10, all the way up to 10 out of 10. And I want to see whether this is larger than 0.99. Nowhere near it. So what do we do? Well, we need to survey more people. Okay, so this n value needs to go larger. So all I'll do is jump back on the calculator and test it. Right, so I'll go up to 30 and 30. So this is 2 out of 30, 3 out of 30, 4 out of 30, and I'm just seeing whether the probability of that is 0.99 or more. Alright, getting closer. Nearly there. Let's go up to 40 and see what happens. Okay, so that's gone over 0.99, so let's pull it back to 39. Still 0. Okay, so I'm basically just trying to get it to fall under 0.99 now. 38. Okay, there it is. So that's it. So what we're going to say is test n equals 10, fail, less than 0.99. Tested n equals 38, fail, less than 0.99. Tested, n equals 39. So we went greater than 0.99. Therefore, n equals 39. So I'm basically trying to rip 2 marks via this method of trial and error, which I assure you is a perfectly legitimate way of doing it. I'm sure if you look up the examiner's report, you'll find that it will show you a more algebraic method of doing this. It'll be like probability that x is equal to 2 plus probability x is equal to 3 plus dot 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 greater than 0.99. And you might remember that what we did was something like that's the same as 1 take away probability x equals 0 plus probability x equals 1 greater than 0.99, and then we subtracted it, negative, that flipped that, and then we would have used NCX, whatever formula you use, success to the x, fail to the n take x, to construct this one and this one, and then you would have solved for, in this case, x, and that would have told you that the answer would have been 39 as well. So yeah, a couple of different ways of doing this, but I think trial and error, or some guided trial and error, is probably the best way. So see how that works for you, and let me know if I can help any further.